The BIG-IP LTM has a number of load balancing options, different methods to distribute service requests. It is important to emphasize that requests are distributed between available servers. Availability is determined by both monitors and management status of both the node and the member. Static load balancing options distribute traffic across members based on predefined patterns. Member availability is taken into account, but current performance is not. Dynamic load balancing options distribute traffic across members based on current server performance and member availability. The chosen matrix for each member is compared and the best member is chosen. Round robin is probably the most commonly used load balancing method. Sites are often more concerned about not sending traffic to members that have failed a monitor or using iRules to distribute traffic intelligently. Round robin distributes connections evenly across available members. This mode is useful for even distribution of traffic among equally capable members. The ratio mode distributes new connections across available members in proportion to a user-defined ratio. Ratio is appropriate when some of the pool members are on more powerful systems than others. The least connection method distributes new connections across available members based on the current connection count per server. Least connections is appropriate when the client connection length varies significantly and round robin could result in uneven loads. The fastest method distributes new connections to the members or nodes that currently have the fewest outstanding Layer 7 requests. When a connection request is received, the member with the fewest outstanding requests is chosen. If the associated virtual server does not have both a TCP and a Layer 7 profile, LTM cannot track requests and responses. Load balancing will fall back to least connections. Fastest method is useful for distributing traffic to devices that may differ in their response time depending on the load that previous requests have placed on the system. Least sessions distribute new connections to members based on current persistence records or sessions associated with that member. Least sessions is appropriate when sessions are long-lived. Weighted least connections requires that each member or node have a non-zero connection limit assigned. Traffic is distributed to the member that has the lowest ratio of connections. The ratio is current sessions divided by maximum allowed sessions. The observed method distributes new connections to members based on system-assigned ratio values. The ratios are assigned based on the load on each member. The predictive method is similar to observed, but assigns more aggressive ratio values. While the load balancing method determines how connection requests are distributed across members, priority group activation determines which members are eligible for use at a given moment. Priority group activation allows you to define primary members and backup members. If priority group activation is set to 0, disabled, priority values are ignored and all members are active. If set to 1, all members of a high priority group must be unavailable before another group is made active. Persistence will work even if it is to a lower priority member that was previously active but is no longer active. If all members of a pool fail, the virtual server can send an HTTP redirect message to the client. This allows the administrator to send customers to an alternative site or an apology server. This option is configured through an HTTP profile. This is the first HTTP-only feature discussed in this course. The HTTP redirect could be to many alternative sites, including an apology server, another virtual server on the same system, or a virtual server in another data center. There is a subtle but significant difference between the member load balancing choices and the node load balancing choices. Specifically, when choosing a member to handle the request, do you want to base the decision on node information or member information? This topic is best described on the next slide. The key is, do you want LTM making a choice based on pool member statistics or node statistics? This shows pool member choice. 99 is less than 107, which is less than 108. This shows node choice. 109 is less than 111, which is less than 124, adding all the connections at the same node or same IP address. If a single server had two IP addresses, the LTM would consider the members at the addresses to be separate nodes. Each pool has the load balance method defined independently. For some load balancing methods, you can set the priority of its members. This slide shows the steps of setting up a ratio method. You click the Node tab, then the node list, select the node, and configure your settings. If 100 requests are sent to this pool, how would they be distributed? Answer: 40 requests go to 20.2 and 60 requests go to 20.3. Why, you ask? Priority determines it's 20.2 and 20.3 only. Load balance determines 2:3 ratio. When we change the load balancing method to round robin and receive 100 requests, 50 requests go to 20.2 and 50 requests go to 20.3. Priority still limits using these devices. When we change the load balancing method to ratio node and receive another 100 requests, this cannot be determined since we do not know the node ratio. The ratio for nodes defaults to 1, so if left at default, this would be the same as round robin. If we change the priority group activation to 1, all 100 requests will go to 20.2. Coming up next, we will configure some load balancing labs. Here are the labs we will do. We are going to explore the network map, then we will configure some load balancing methods.